So we're going to take a look at exercise 12 out of 12.1. So below are the amounts of arsenic in samples of brown rice from 3 different states. The amounts are in micrograms of arsenic, and all the samples have the same serving size. The data is from the Food and Drug Administration, and they want us to use a 0.05 significance level to test the claim that the 3 samples are from populations with the same mean. And then they give us a couple additional questions. Do the amounts of arsenic appear to be different in the different states? That's kind of what we're testing here. Given that the amounts of arsenic in the samples from Texas have the highest sample mean, so from our sample data, the Texas data has the highest mean, can we conclude that the brown rice from Texas poses the greatest health problem? So we'll address all these. We'll address all of these. Let's see. We'll address these problems after we go ahead and complete the test. So our claim is that the mean from Arkansas is equal to the mean amount of arsenic from our data from California is equal to the mean from from our population from Texas there. And our opposite of that is going to be at least 1 is different. At least 1 population mean is different. So to go ahead and write out our hypothesis statement, we can use symbols for the null hypothesis. And this is the case where they're all going to be equal to each other because the null always has the equal case. And our alternate hypothesis is that they're not all the same, they're not as listed above, or at least 1 population mean is different. And that phrasing allows for 2 of them to possibly be the same, but the third one being different. And then, as we've been doing, the R and the S, and it is the null hypothesis that represents the claim there. So when we get down to the conclusion, we'll talk about whether or not we can reject this claim that all 3 samples are from populations with the same mean. So they want us to identify the significance level and use it to write our rule of rejection. So we're going to reject null hypothesis if the p-value is less than or equal to this 0.05. And then now that we've got all that, we're ready for our test statistic, which in this case is F, and we're ready for its corresponding p-value. And for that, we're going to have to go over to StatDisk. And because I know it's really exciting to watch me type in data, so I apologize for depriving you of that opportunity. I typed it in ahead of time. I will mention when we enter data into StatDisk, it has to be column oriented. So in the first column, there's all the Arkansas data. Second column, there's the California data. Third column, there is the Texas data. So we're going to go analysis, one-way analysis of variance, because we're only breaking up the data one way. We're breaking it up by state. Our data is in the first 3 columns. Our significance level is 0.05. We can hit evaluate, and we can hit plot. And what we see is we do see that our blue vertical line representing the test statistic is well off in that right tail there. So I'm gonna copy our dialog box over. And well, that's a little bit of a mess, but so what's important here is our test statistic and our p-value. 1, 2, 3, 4, 5 zeros. So 1, 2, 3, 4, 5 zeros, then the 1, and the 22.948. So our p-value is definitely smaller than our alpha, our significance level. So we are going to reject the null hypothesis. And when we reject the null hypothesis, that means that we have the evidence. So we have sufficient evidence to see, and we starred the R, so R is for reject. Reject the claim that. And then lastly, we're going to write down what the claim was. And that's the 3 samples are from populations with the same mean. And as always, we should go back and reread this all the way through. We have sufficient evidence to reject the claim that the 3 samples are from a population with the same mean. So they don't all have the same mean. So what we're saying is at least one of them is different from the others. So now, this is where things can get a little bit interesting in how you follow up when you reject the null hypothesis. If you fail to reject the null hypothesis, you don't have the evidence to believe that any are different. So if you can't say any are different, you don't go looking for differences. You're basically stuck with that they all appear to be the same. The means all appear to be the same. When we do reject the null hypothesis, it's possible that all 3 means are different. It's possible that one is larger than the other 2, which might be the same, or one is smaller than the other 2, which might be the same. And how we go ahead and explore for that, there's 2 ways that we can explore this. So they asked us the question, well, Texas, the sample mean from Texas was higher than the other 2. I think that's obvious. I'm going to go back to, oh, sorry. I'm going to go back to StatDisk here. So we can get rid of that, get rid of that. So I think it's kind of obvious from looking at column 3 here that, you know, that the Texas numbers appear to be larger than the other 2. You know, its smallest number is the, you know, group 2's maximum and well up in the other one. But we want to do more than just how we feel about it. There are formal methods of going in and doing the testing. We're not going to go down that road. We're going to do some quick eyeball stuff. And our first eyeball method it's the most informal method that we're going to look at here. We're going to take a look at the box plot of our data. And it doesn't matter if it's a box plot or a modified box plot, because we're not going to look at anything other than the box. We're not going to worry about the whiskers heading off to maximum and minimum. So when we're taking a look at this, what we're looking for, and the reason that we're just looking at the boxes, is we're comparing means. One of our assumptions is our data is fairly close to normal. So if our data is close to normal, normal is a symmetric distribution, which means your measures of center should be equal to each other. Your mean and the median should be pretty close to one and the same. So the box represents the middle 50% of the data. So from the underlying assumptions, the mean should live within the box that we're seeing in our box plot here. So what we see in columns 1 and 2 is these boxes overlap. So in our informal look, since these two boxes are overlapping, we can't say that they're different. This is kind of the same sort of comparison we made with two confidence intervals. If they overlap, can't say they're different. If they don't overlap, we can say that they're different. And that brings us to column 3, which is the Texas data. The box for column 3 does not overlap with either of the other boxes. So we can definitely say here that, or we can say here that our mean for our Texas rice is going to be higher than that of the other two. Looking at the box plots, we can't really say that there's a difference between the means between the Arkansas and the California rice. So this is our kind of the quick and dirtiest way of looking at this. It's the most informal way of looking at us. If we wanted to go a little bit more formal, we would go confidence intervals of the mean, which might be the reason why Triola had us comparing them pairwise, even though he told us back in chapter 7 we shouldn't do that. He still made us do that. So, and one of the ways we can quickly get confidence intervals of the mean is to just do the explore column. And the bottom of the dialog box, we get the confidence intervals. So I did that for column 3. I'm going to do that for column 2. And let's do this for column 1. And let's make all this stuff visible here. And, I want to be able to write on this, so let me just take this back to OneNote. Okay. So I'm going to go off to the side here to bring this back. So there are our confidence intervals, and then just that's Arkansas, that's California, that's Texas. And what we see is these two still overlap. The top of California is higher than the bottom of Arkansas. So there is overlap between those two, but if we look on the high side of each, they're both below the bottom of the Texas one. So what we saw in the box plot, we're seeing a consistent thing with the confidence intervals. So our very informal method and our just a little bit informal method of comparing individual confidence intervals, both allow us to go ahead and say that the mean for Texas is higher than the mean for Arkansas, and the mean for Texas is higher than the mean for California. So we can say population-wise, our rice from Texas has a higher mean amount of arsenic from the other two. So we can conclude that, but we can't conclude that it had the highest mean just because we rejected it alone. We had to do that little bit of extra work to confirm that statement. Now, can we conclude that brown rice for Texas poses the greatest health problem? Well, arsenic is a poison. So if we have too much of it, well, hell, if we have just about too much of anything in our system, it becomes toxic. I mean, people drowned. So does it pose the greatest health problem? Well, relative to the other rices, I suppose. I'm not sure how much arsenic you need to have in your system before it actually becomes a problem. That would be information nice to know. I don't know if arsenic builds up in your system over time or if our body can process it out, so unless we're eating rice from Texas constantly, that we'd get to a dangerous state before the other two states. And I'm only being somewhat facetious here because this is where our knowledge of context really comes into play. If we were doing this out in the real world, we would probably know a lot more about arsenic, and we'd have a lot more background knowledge about what's going on. So in just the very broadest terms, we can answer yes here. Now, does that mean when you leave here and go to the supermarket, you should make sure your rice isn't from Texas? That's probably something we want to do a little bit more reading up before you start worrying about it. And what we'd hope, if it was that much of a problem, that the FDA would have jumped in at this point. So I think
a little busy these days.
Yeah, a little busy these days. Anything else you want to mention?
No, the snide comment I was just about to make, I'm just going to stop. So